Good day, class. It's Sir Capistana again, and welcome back to another discussion here in Chem 21. Wherein for today, we'll be talking about ethers. And by ethers, as you may see here, I have here an example of somehow a complex ether. This is actually an example of a crown ether, or one of the examples of crown ethers. And to be exact, this crown ether is actually what we call 1, 4, 7, 10, 13, 16, 19 heptaoxycyclohexane. So, yeah. So, this is actually one example of what we call phase transfer catalyst. So, by phase transfer catalyst, this type of catalyst is actually used for certain reactions. By reactions, one of those examples are the ion reactions that we may encounter. So, transfer catalyst, or what usually called PTC, is a catalyst that facilitates the migration of reactant from one phase into another phase where the reaction occurs. So phase transfer catalyst is a special form of catalyst wherein by special form of catalyst it is actually a heterogeneous or heterogeneous catalyst wherein for example in ionic reactants are often soluble in aqueous phase but is insoluble in their organic phase. So in the absence of phase transfer catalyst. So the catalyst functions just like a detergent kung isipin natin. It is a detergent that make salts soluble in organic phase. So yun yung isang gamit ng ating mga crown ethers. Pero hindi lang ito actually ang example of crown ethers. I just chose this because it has seven oxygen and seven is a lucky number. But in any case, let's move on into the basics first before we actually are introduced into these crown ethers. Kasi as far as I may remember, crown ethers are actually important in biochemistry. Hindi lang ako masyadong sure kasi hindi ako nagtuturo ng biochemistry. But for now, dun muna tayo sa basics. So by ethers these are actually organic compound wherein we have two organic groups that are attached to an sp3 hybridized oxygen atom. And by sp3 hybridized oxygen atom, if we just recognize an oxygen atom, so we have remembered it can form two bonds wherein if we have here these two bonds and we have here this lone pairs, as you can see here, there are actually four bonding sites here. So as you may have remembered, this bond or this site will be sp3 hybridized. So is this lone pair, ito ring lone pair na to, and this bond. So we have actually here four sp3 uh, sp3 orbitals per se. So that is our sp3 hybridized oxygen. So it just means that we may have here two organic groups that are attached to those to that sp3 hybridized atom. So pero hindi ibig sabihin na sinulat ko yung R dito ay R lang, or let's say alkyl lang ang pwedeng mangyari yan. But to be exact, when we talk about ethers, what actually happens is we have here our oxygen in the middle. Then we will have here our carbon and another carbon here. For that carbon, it may have different substituents. It can be a hydrogen or uh, other groups. So this form or this structure is actually what we call an ether linkage. Okay? Wherein, if we talk about ethers, our ether group is actually our oxygen atom. Meaning to say, when we are talking about the functional group, ang functional group lang natin dito ay yung ating oxygen. Uh, having the sp3 hybridization. Okay, so this is our functional group, and this will be our general structure. Okay, so in that, we may actually encounter different types of ether. So we have this classification of ethers. So we have here dialkyl ether, we have alkyl aryl ether, and dark diaryl ether. So ano ba yung magiging structure nito? So for dialkyl ether, I have here one example. Ang ibig lang sabihin ng dialkyl ether, ibig sabihin kung andito yung ating oxygen, we will be having two alkyl groups that is attached to that oxygen. Meaning to say, it can be like this. So we have here a propyl. So we notice we have one, two, three. That is an alkyl group. Then we can have this group wherein we have here an ethyl. So we have here a propyl ethyl ether. Okay? And for aryl ether, it just means that if we have an aryl here by aryl, that is actually our benzene ring or our benzene. Then our benzene is attached to an oxygen, and that oxygen is again bonded into another R group. Say we have here our CH3. So as you can see here, we have here an alkyl and we have here an aryl group. And for diaryl ether, by its name, just means that we will have two benzene rings here that are bonded to an oxygen. Okay? Pero hindi lang yan yung pwedeng maging form natin, as you may have remembered when we are talking about aromatic groups just like our benzene, we can have other substituents that are attached to that aryl, okay, or aryl group, right? So in here, our R here is our alkyl group and our AR is our aryl group. Okay? And besides that classification of ethers based on the groups or organic groups that are attached to our sp3 hybridized carbon, we also have other classification of ethers wherein we can actually further simplify our ethers into symmetrical and unsymmetrical ethers. So as you may have noticed here, dun sa mga examples sa binigay natin kanina, one of our symmetrical aryl here is our diaryl ether here. Or some example may, one of the simplest example may be this, our methoxymethane, wherein on both sides of the oxygen group, or the oxygen, or the functional group, both sides of the oxygen have the same group. So both of the side have has CH3. And for unsymmetrical, we have here this example, or pwede rin ito, itong nasa gitna, itong ating alkyl aryl ether that is also symmetrical. And another example maybe if we have here CH3, CH2, then we have our oxygen here, and we have here CH3. This is one of the most basic example of our uh, unsymmetrical ether. Okay? So those are the classifications of ether. We can classify ethers based on the types of the groups that is attached to our sp3 hybridized carbon. If we have two alkyl groups, that is dialkyl ether. If we have one alkyl group and one aryl group, that will be an alkyl aryl ether. And if we have two aryl group, so that will be diaryl ether. And if we can also classify ethers based on the symmetrical, or the similarity of the groups that are attached to our sp3 hybridized oxygen, wherein for symmetrical, both of the groups are similar, and for unsymmetrical, syempre ayun yung dissimilar natin. Okay? And as we are done with the classification of ethers, let's move on into the nomenclature of ethers. Just like any other functional groups, we can have common names for our organic ethers. And just like the nomenclature of other or our previously discussed organic groups or functional groups, as you may have remembered, it only works for uh, representatives that are usually simple alkyl or aryl groups. Pero kapag hindi na sila simple, medyo nagkakaroon na tayong problema. So, for common names of ether, we just be mentioning the organic groups, then writing the word ether. So if we have unsymmetrical organic groups, we will be mentioning the names of the organic groups in alphabetical order. So as you can see here for our first example, we actually have here uh, unsymmetrical ether. Because as you may notice here, nandito yung oxygen natin and we have four carbons in this side and one carbon on this side. So this one carbon group will be our methane. And we have here four, so that means it is butane. So BM, so that will be butyl methyl ether. So as simple as that. You just need to mention the names of the groups that are attached to our oxygen. And for symmetrical ethers, we will be using the prefix di. We may use that prefix di to the word ether. So, pwede yung mangyari since, for example, we have here one, two, three. So, that is profile. Again, we have here on this side, we have one, two, three. Again, that is profile. Meaning kasi we have two propyl groups on each side of the oxygen. So, we can actually write that as dipropyl ether for its common name. But at some cases, we can actually drop this di. And if we just write propyl ether, ibig sabihin na niyan, on each side of the oxygen, we have two propyl groups. One for one side and one for the other. So, that is how we name our symmetrical ethers. And lastly, we have here an aryl alkyl group or an alkyl aryl ether, wherein we have here our methyl and we have here our aromatic group, which we call actually benzene. So for this one, for its common name, this will be benzyl. Why benzyl first? Because B comes first before M. So then we have there our methyl ether. So we have here our benzyl methyl ether. Okay, so as simple as that. That is our nomenclature of ethers, which will actually uh, look simpler than the IUPAC method of naming this organic compounds. So let's jump right into it. So for the IUPAC or IUPAC naming, we have here these rules wherein let me just read the rules. For the smaller alkyl group and the ether oxygen are taken together as alkoxy group. The alkoxy group is treated as substituent of the larger organic group. So for the naming, name the alkoxy group by identifying the corresponding alcohol and replace anol ending with oxy. So then follow the same rules for naming alkanes. And if larger group is an aryl, name the ether as alkooxyrene or alkooxyarine by following the same rules as naming aromatic compounds. So, anong ibig sabihin lang nun? So, for this example, kanina, 'di ba, ang pangalan lang ito, we have here a butyl methyl ether. But for this time, sabi ron sa first rule, we just need to get the smaller alkyl group, then the ether oxygen. That means we have this group And that group will actually be treated as substituent of the larger organic groups. Meaning to say, we have this larger organic group, this butane. Then, if you may have remembered, this is actually a methoxide or methanol. So for methanol, we just need to replace anol with oxy, which just means that will be methoxy. Okay? So this group will be named methoxy. So how about this one? So as the rule states, we'll be following the same rules. And since we treat this group as a substituent, it just means that we will be assigning a position number na we will be assigning the lowest possible position number. So, pag dito tayo nag-start, that will be 1, 2, 3. So, no. Kasi, meron tayo ditong 1, 2. So, itong dalawa yung gagamitin natin. It just means that our methoxy is actually attached to our second carbon. So, we have here 2 methoxy. Then, we just mention this group. So, that will be butane. So, in that, we have 2-methoxybutane. So, for this one, yung maalala nyo kanina, same yan, ano? We have here 3, then we have here 3. So, paano yun? So, since same lang naman sila, ang pwede nyong gawin, you just treat the other one as the methoxy group. Sa halimbawa, ito yung yung methoxy group natin, then ito yung larger chain natin. So what we can do there is we just name this. So that will be propanol. So imbes na propanol, we just remove this anol, okay, and replace it with oxy. So we have there propoxy. Then position number, the lowest position number is 1. Okay, so that will be 1 profoxy propane. Okay? And for this one, we have here an aryl compound. So this is a benzene. So that is the larger group. So this will be our substituent. So it just means that we will have their methoxy benzene. Okay? So bakit hindi ko nilagay na yung number niya? Kasi as you may notice there, since cyclic yung ating benzene, and isa lang naman yung substituent niya, it is counted na nandun siya sa first or dun sa 1. Okay? So that is some of the ways on how we will be naming our ethers or under our IUPAC naming. So in that, just like other uh, just like other functional groups, we may encounter what we call cyclic ethers. And by cyclic ethers, we actually have some special names for cyclic ethers. And by cyclic ethers, these are cyclic analogs or cyclic organic compounds that bears as an ether group in the part of the ring or nandun yung ether group natin dun sa ring mismo. And as you can see here, we have here different names or different ways how we will be naming our cyclic ethers. Okay? So in here, we have here for this one, we have here an three-sided or three-membered ether. Here we have oxirane, oxetane for 3 carbon atoms and 1 oxygen. We have here oxolane, furan for having the double bond, and we have there the oxane. We have here the 4H pyran and the 2H pyran, the oxyphane and the oxophane. Okay? So, baka nagtataka sa inyo bakit 4H yung isa, bakit 2H yung isa. Actually, kung titingnan nyo lang, 4 hydrogen, ang ibig sabihin, we will be having there 4 hydrogens in between 2 of the bonds na hindi kasama yung oxygen natin. So, just means na dalawa yung hydrogen dito, and we have another hydrogen here and another hydrogen here. And for the 2H, yung mga hydrogens natin ay nandyan lang. So, 2H. So, hanggang ngayon, hindi ko pa rin alam kung paano yung system or paano yung pattern, kung paano ma-memorize tong naming nila. But, ayun, hindi ko naman sila masyadong gagamitin sa ating discussions. But for the system mismo, syempre kasi we may be encountering some of these cyclic ethers that may have substituents. And for those substituted cyclic ethers, we will be naming them using the ring as the parent group. And the ring atoms are numbered by giving the position 1 to the ether oxygen and giving the lowest possible position to the remaining substituent. So for this example, ang ibig lang sabihin nun dun sa rule natin dyan, dapat yung position 1 lagi ay nandoon ay binibigay natin dun sa ating uh, oxygen. And for that case, since iisa lang naman yung substituent natin dito, we will just be naming this as methyl oxyring. Sir, bakit wala yung position number? Kasi noted na siya. Once na you have an oxyring or a cyclic ether, tapos iisa lang yung substituent, tapos nagkataon pa na oxyring ito. If you have position 1 for our ether oxygen, ibig sabihin, 'to na agad yung sa kasunod. So, hindi na siya sinusulat. Unless you will be having other substituents here. Just like in this oxolane. Kita nyo rito, we have here an oxolane. Oxolane may have 4 different positions or carbon positions. So, we need to name this. Ibig sabihin yan, or we need to provide that numbering to our methyl there. So, we will have here 2 methyl oxolane. Kasi hindi magiging automatic, ay not 2, that should be 3. Okay? Kasi ito po ay 2. Okay. So, we have here 3 methyl oxolane. Okay? So, hopefully, ay nagkaintindihan tayo sa nomenclature ng ating ethers. So, for the next part, we will be having the physical properties of ethers. And just like our alcohols and phenols, our ethers are actually slightly polar. This is due to the polar ether linkage na tinatawag natin. So ano ba yung sinasabi nating polar ether linkage? Gawa mismo nung oxygen natin. So if you have here an R group and another R group, you may have remembered oxygen actually have 2 lone pairs. So due to the presence of these lone pairs, we actually have slight polarity here, wherein this will be partially positive due to the presence of our R groups, and this side, due to the presence of the lone pair, we will have here a partially negative sides for our ethers. And in that, due to that slight polarity, we may expect a higher intermolecular forces between each ether molecules with each other. Pero ito yung problema. We don't we will not be expecting hydrogen bonding between ether molecules because as you may have remembered, hydrogen bonds may exist kapag meron lang tayong sandwich na nangyayari. In our hydrogen sandwich, isa-sandwich niya yung high electron may yung atom na may mataas na electron affinity. And for this case, hindi yun mangyayari dito sa ating kung ether to ether. But However, they are capable of hydrogen bonding with water. So meaning to say, some smaller ethers are actually slightly soluble in water, and some larger ethers are actually insoluble in water. Okay? And if you are to compare, dahil dun sa case na yon na kokonti yung hydrogen bonding between ether molecules, you can expect that we have actually lower boiling points when we are to compare ethers to alcohol. So for example, let's take functional isomers na ito. So we have here our ethoxyethane and our alcohol here, our butanol. As you may notice here, parehas actually sila ng chemical formula, wherein we have C4H36 for H10O, and ganoon din para dito sa ating alcohol, ano. So we have here C4H10O. So as you may have remembered, they are actually functional isomers. So by being functional isomers, meaning siguro parehas sila ng molecular weight, ano, kasi parehas sila ng atoms na involved dun sa molecules nila. But if we are to compare their boiling points, as you may notice here, uh, bibigay ko lang pala na. So we have here 36.4 degrees Celsius ang boiling point ng ating ethers. And it for the alcohol, as you may have remembered, for butanol, we actually have 117 to 118 degrees Celsius ang kanyang boiling point. So that is just because of or gawa lang yun actually, nung hindi kasi capable yung ating ether na mag-form ng hydrogen bonding between ether molecules. So we have here our ethoxyethane and our 1-butanol having the same molecular weight, actually have a large difference regarding their boiling point. And kung sanay na kayo sa klase natin, ibig sabihin lang niyan kapag sobrang laki ng difference nung sa boiling point, isa lang ibig sabihin niyan. Sobrang para dun sa alcohol, mas mataas yung intermolecular forces that are involved na nag-exist dun sa ating alcohol molecules kaysa dun sa ating ether molecules. And kung i-compare natin actually to sa medyo katulad nila ng molecular weight, yung ating pentane. Okay? Ang pentane ay may molecular weight na 72 at ang kanyang boiling point actually ay 36.1 degrees Celsius. So you may notice here, mas mataas pa yung naging intermolecular forces natin dun sa pentane in comparison with this ether. Okay? That is due to that slight polarity, that no hydrogen bonding between ether molecules, and nagkakaroon tayo ng ganyang difference. So in that, let's have the reactions within ether. But before that, let's first discuss the preparation of ether. There are actually two ways. Hindi pala two ways. There are actually one way on how we can synthesize. By synthesize, ito ay hindi natural na nangyayari. So we have here, ethers can be prepared using what we call Williamson ether synthesis. This is actually a nucleophilic substitution. By nucleophilic substitution, we actually have here an SN2, or our bimolecular nucleophilic substitution. Meaning to say, ang nangyayari dito sa Williamson ether synthesis, when we actually introduce the nucleophile on our substrate na gagamitin natin para dun sa synthesis ng ether, mag-a-attach tong nucleophile dun sa dun sa substrate natin hanggat nang hindi pa umaalis yung leaving group. And by living group, ethers can actually be synthesized using at the minimum primary ethers. Okay? And by ethers, sorry, primary alkyl halides. And by in that, if you want to prepare dialkyl ether, what we need to do is we just need to introduce a nucleophile alkoxide, and in that we will have a diethyl ether wherein we will have here our original group for our alkyl halide that will be bonded to our OR. Okay? So, para lang malinaw, this is R1, R2, this is R1, R2. And if we want to synthesize alkyl aryl ethers, syempre, we will be using our phenoxide. So, for our phenoxide, tama, phenoxide. And in that, we will be having this products wherein we will have here our R1, carbon there that is attached to our phenoxide. So, as you can see here, we have here a dialkyl ether, and we have here an alkyl aryl ether. So, the synthesis of ether is actually based kung ano yung gusto mong produce na ethers natin. Okay, so in that, the next part of the discussion is regarding reactions of ethers, wherein when we talk about reactions of ethers, one of the most characteristic or the characteristic reactions of ethers actually involves the cleaving or the cleavage of the ether linkages. So in that, ethers being unreactive, kailangan natin actually mag-introduce ng heat and concentrated acid. So in that, one of the cleavage na tinatawag natin is the cleavage of carbon-oxygen bond of dialkyl ethers. So by dialkyl ethers, we will be having this formula. So wherein we have there our group, the ether oxygen, and our uh, our next R group. So in that, we need to introduce a strong acid, and one of the strong acids is our hydrogen halides. Mapa HCl man yan, HBr, HI. Okay? And also, we need to introduce heat for the reaction to occur. So, and based on this reaction, what will happen here is we will have a break here, and due to that breaking, we will have here an ROH plus our R prime X. And kapag merong actually excess na na acid, what may pwedeng mangyari ay yung itong itong ROH natin will still undergo reaction excess if we have excess acid, tapos syempre andyan pa rin yung heat, what will happen is we will have here Rx plus H2O. Okay? So that is the full reaction mechanism of the cleavage of CO or carbon-oxygen bond of dialkyl ethers. So kapag enough lang yung yung ginamit nating acids, pwede tayong mag-produce ng ating alcohol and saka alkyl halide. But if we have excess acid and continuous yung heat nung sa system, we will actually produce two types of alkyl halides, especially when we have symmetrical and unsymmetrical ethers here. Okay, so in that we have there our cleavage of carbon-oxygen bond in dialkyl ethers, and we also have the cleavage of carbon-oxygen bond of alkyl aryl ethers. And for in that, we have this general formula uh, for our alkyl aryl ethers. So, ganun lang din, we need to add acid. Dapat concentrated yung acid in the presence of heat kasi kung walang heat, hindi mag-occur yung reaction. And in that, we'll be having our phenol here plus yung ating alkyl halide. So magtatanong kayo, bakit sir, dyan yung naging break dun sa oxygen at saka dun sa carbon ng ating R group? As you may have remembered, aryl compounds or yung tinatawag natin yung may benzene ring natin or ating aromatic hydrocarbons actually are more stable than any other chain or hydrocarbon chain. So in that, the cleaving or the break of the bond, or to be specific, the breaking or the cleavage of the carbon-oxygen bond will occur at the oxygen, ether oxygen, and the R group. Hindi siya mag-occur dun sa ating aril. So, in that, kung itutuloy mo yung process wherein meron kang excess na acid, tapos meron kang nandyan pa rin yung heat, magpo-produce kaya ito ng ating aryl halide plus water? Actually, no. Hindi mag-occur yung process kasi phenol being a stable molecule, hindi niya hindi mangyayari yung tinatawag nating hindi mangyayari yung substitution reaction. But pwede actually mag-occur ay magkaroon ng addition na lang or kumbaga magkakaroon tayo ng EAS dun sa ating aryl compound rather than substitution ng ating OH at saka ng ating halide. And so in that, let me introduce, actually, remind you regarding another reaction where is wherein we will be talking about our electrophilic aromatic substitution. So, alkyl ethers are essentially aromatic ethers. So, being an aromatic group, it can actually undergo what we call electrophilic aromatic substitution. So, and as you may have remembered, our OR group is actually a moderate activator. By moderate activator, it just means that it activates all of the sides of our benzene ring wherein ang mas na-activate ay yung ating ortho and para directions or kaya tinawag natin silang ortho para directors. So, it just means here that if we're considering this position of the substituents at mag-a-add tayo ng panibagong substituent, saan sila mag-a-attach? So, majority or major of the majority of the products will actually have the substituent attached to the ortho and para direction of our alkyl aryl esters. So, mas probable itong mangyari kaysa sa tinatawag nating cleavage of CO bond kapag in the presence of concentrated acid and heat. Okay? So, mas i-favor nila. And the last set of the reactions that occurs in ethers actually happens to our three-membered cyclic ethers we call epoxides. And one of the simplest epoxides is our oxirane. Okay? So, cyclic ethers with three ring atoms, or yung example natin nga, yung oxiranes are called epoxides. So these epoxides actually undergo ring opening due to the considerable ring strain tulad nung sa cyclopentane natin dati. And that ring opening reactions of symmetrical epoxides, ang nangyayari, pwede magkakaroon tayo actually ng different products depending kung ano yung type ng epoxide na pinag-uusapan natin. And by ethers, we actually have Symmetrical ethers, meaning we will be having symmetrical epoxides. So by symmetrical epoxides, one of the most basic examples of our symmetrical epoxides is actually our oxirane, wherein our oxirane actually has this form wherein we have here a hydrogen and another hydrogen here. We have hydrogen here and another hydrogen here. So this ring opening actually happens upon the introduction of a nucleophile. And if we add nucleophile to this oxyring, what will happen is this nucleophile will actually break either of these bonds, carbon and hydrogen bonds. Kasi symmetrical naman siya kahit anong side siya mag-attack. So let's say that instead of breaking this side, it breaks this side. Okay? So, dahil dyan, we will have this intermediate product wherein we will have there the nucleophile attach itself to the carbon rather than the oxygen. Kasi, syempre, nucleophile being an electron-dense atom or molecule or ano man, mas pipiliin niyang mag-attach dun sa proton rich, unlike our oxygen that is actually electron rich, and we will have this form wherein our oxygen is there, it will be negatively charged. Wala na pala yung negative charge nito. Then upon adding our H plus or our acid, we will have this compound. So basically, if we have oxirane, we will be actually producing an alcohol and na may naka-attach na nucleophile. Kung ano bang nucleophile yan. Mapa-halide man siya, conjugate bases man yan, or kung ano man. So that is the ring opening of symmetrical epoxides. So, linawin ko lang, that ring opening can also happen to the other side. Pwedeng dito siya, mag-pour sa side na to, kasi dahil nga symmetrical sila. Okay? So, how about unsymmetrical epoxides? Actually, for unsymmetrical epoxides, we actually have two conditions or two types of ring opening reactions regarding these epoxides. So, first reaction is our acid catalyzed ring opening. So, for acid catalyzed ring opening, by its name itself, the reaction was catalyzed using acids. So in that reaction, if you have this unsymmetrical epoxide, so we have there our oxygen, our three-member ring here, then we have here our hydrogen, and then we have here an R group, making this unsymmetrical. So if we introduce acid here, so acid catalyzed, what will happen is we will be having an intermediate product here, wherein we will have here an oxyran. By oxyran, this is actually an ion bearing a positive charge about our oxygen there. Then we will have here our hydrogen. Ay, tumutan ko yung R group. Then yung hydrogens natin dito. So that will be our oxyran. So ang next na mangyayari, if we added our nucleophile, it will actually attack the more substituted ring carbon. So meaning to say that will attack there, okay? So we will have this molecule wherein our nucleophile will be attached to the more substituted carbon. Then we will have here this OH here. So Kung meron kang acid, syempre meron ka ring base catalyzed. And for the base catalyzed, as the name states, the reaction is also actually catalyzed by a base. And by base, unang inintroduce yung nucleophile natin bago yung acid natin. So, having the same example there, having that unsymmetrical oxirane or epoxide, okay? If we introduce our nucleophile here, what will happen is it will actually attack the less substituted carbon atom. So, ibig sabihin, imbis na nandun siya sa may attachment ng R dito sa kabila, therefore producing this compound wherein we will have here an oxygen, then we will have here an R group, then andito yung ating hydrogen, and yung nucleophile. Okay? And upon addition of our acid, syempre, doon ang punta niyan, for sure. So, we will have this compound. Okay? So, that is the difference between the ring opening of unsymmetrical epoxides to the symmetrical epoxides. And we also have here two types or two mechanisms for the ring opening of unsymmetrical epoxides. We have here the acid catalyzed reaction, and we also have this base catalyzed reaction. So for the acid catalyzed reaction, syempre, inuna lang natin yung base. Then due to that base, we will have here an oxyran ion. And that oxyran upon the attack of the nucleophile will attack the more substituted ring carbon, therefore having that molecule or that product. And for the base catalyze, ang nauunang nangyari ay idadagdag muna natin yung nucleophile natin, and due to that addition of nucleophile, the less substituted carbon will be detached from the oxygen or the ether oxygen. Then, kasi doon mag-a-attach yung nucleophile natin. Then, upon the addition of acid, the acid or the hydrogen will actually attach itself to the oxygen. So, having the oxygen attached to the more substituted carbon atom. Okay? So, that will be all for the reactions of ethers. So, uh, for this video, we actually, mukhang mahaba na tong video na to. We introduce ethers, we introduce the general formula of different types of ethers or different classification of ethers. We discussed nomenclatures of ethers and cyclic ethers, also the physical properties of ethers, preparation of ethers, and the reaction of ethers. So in that, we'll be ending this video, and for a small announcement, this actually ends the midterm lecture. By end of midterm lecture, this is the end of the midterm coverage for this class. Meaning to say, lahat nung diniscuss natin from the start of the semester up to this point will be the coverage of our midterm exam. So, bakit ko pinaaga yung tapos ng midterm exam? So, at least you can have another week, another 1.5 week for preparations. But I will still be conducting lectures, and I will still be giving you lectures like this or videos like this on continuation of our class. Wherein for the next meeting, I will be actually talking about carbonyl compounds. And carbonyl compounds actually are made up of the aldehydes and ketones. Then few more topics. Then we will be having carbohydrates. We will be having amino acids. Amines yata. Hindi pala. Carboxylic acids pala muna and its derivatives. Meaning to say, derivatives ng carboxylic acid. Andyan yung acid halides, acid anhydrides, yung esters, yung amides, and after that, we will be talking about fatty acids, if I'm not mistaken, or fats and oils, then amines, amides, then amino acids. And that will be for your final exam. But for the midterms exam, we will be having functional groups. Then we have here, there are isomers, the reaction mechanisms of alkanes or kahit hindi alkanes, and we have the stereochemistry, the reaction mechanisms, the alkenes, the alkynes, alkyl halides, alcohols, phenols, and ethers. In that, good luck in your studying, and good luck for dun sa review niya. So, have a good one. Bye-bye.